Previously we were looking at the perceptron learning rule, and in perceptron learning rule, we looked at the steps to be followed. Right, the first step was to initialize the weights and bias. Right, basically we define it to be 0, and then we define a new value called threshold that is denoted as theta. Also, we use the learning constant, which is called as a learning rate alpha, and normally it is between 0 to 1, and we actually calculate the partial output z by using the bias inputs and the weights defined. Okay, then the final output is y, that can be derived from the partial output obtained earlier, right? So that is y is equal to sigma of z, that is defined in the following fashion, right? If z is greater than theta, you define it as 1. If it is between the minus theta and plus theta, it's 0. Otherwise, it is minus 1. So the plot of this curve looks like this, and then we look at the update. Whether to update the weights and bias or not, we can identify by just looking at the target and the present output. So if targets and the outputs are matching, do not update, right? Otherwise, you update the weights and the bias using these equations. Then we looked at a few examples, right? The AND operation and the OR operations, we try to implement. Okay, but this perceptron rule is actually a little bit advanced than what we have seen so far. So we'll consider another example to understand this process in depth. So this is a question that is to perform the perceptron learning rule to classify the following data sets. Okay, so the data sets are as follows: 1, 1, 1, 1, and let's say we have -1, 1, -1, -1. So these two should belong to class 1. Okay, so for class 1, and there is another data set that is 1, 1, 1, -1, and 1, -1, -1 plus 1. Okay, so this is for the other class. So let's define the other class as -1. So the idea is, whenever I give the first two data, one of the data, right, like 1, 1, 1, 1 or -1, 1, -1, -1, the perceptron should give you an answer like +1. And whenever you give the other two, that is 1, 1, 1, -1 or 1, -1, -1 plus 1, right? Whenever I give the second one of the second sets of data, it should give you an answer -1, indicating that they belong to the -1 class. Okay, so let's follow the same procedure we followed for the previous example. So we have to initialize the weights. So 4 inputs are there. So how many weights we need? We need 4 weights. So W1 equal to W2 equal to W3 equal to W4 equated to be 0. And there is a bias. B is also equal to 0. Right. So since it is a binary classifier, we know that we can assume the alpha learning rate to be equal to 1, and only 2 classes. So I don't want multiple classes to be defined. So up to 3 classes we can go for, like +1, 0, and -1 for each of the perceptron. But here we know that since there are only two classes, you can make theta 0. So greater than 0, it's one class, lesser than 0, it's the other class. Okay, so this is the initialization part. So once we do the initialization, right, we have to give the data one by one, and we should uh, calculate the outputs, and we have to check whether we need to update the weights or not. Okay, so let's do this. So first, give the input. So x is equal to, we'll give the input in the same order as defined. So whatever is the given data, we'll give 1, 1, 1, 1 first, and it belongs to class 1. Okay, so x is equal to, I'll give the inputs as 1, 1, 1, 1. Okay, and I know that my target is equal to 1. So let's calculate z. Z is equal to w1 x1. Every weight is 0, correct? So and inputs are 1. So every weight into input gives you 0 plus 0 plus 0 plus 0, and even the bias is 0. So this is equal to 0. So you see this is not equal to target. Okay, it's just z. Sorry, I cannot compare this directly. I just have to apply this and I have to find. Okay, so z, I got z is equal to 0. Calculate y. So y is equal to sigma of z, that is sigma of 0. Sigma of 0 is 0. So you see this is not equal to the target, right? So whenever the output of the neuron is not equal to the target, this implies you need to update. Okay, so we used similar equations we used earlier for the updation, correct? So you can see that the next wi plus 1 is equal to wi plus alpha into target into xi. All right, so my weight w1 becomes old weight plus alpha is 1, target is 1, into the input is 1, so w1 is equal to 1. Okay, so w2 becomes equal to, it's also, since it is 0 earlier 0 and now alpha t and x I are ones, this is also 1. Similarly you can calculate w3 is 0, initial value 0, and the updation coefficient will be 1, so it is 1. And w4 is also 0 plus 1, so all the four weights will become 1 now. Okay, and we'll check the updation equation for the bias ones. So see, bias updation is equal to, right, the old bias plus alpha into t itself, correct? So bias update bi plus 1 is equal to bi plus alpha t. The bias doesn't depend upon the input. Bias is just dependent on the past bias value plus alpha into t, correct? So when I try to update the bias now, so b is equal to old value plus alpha into t. Alpha is 1, t is also 1, so this is equal to 1. So all the four values got updated in this case, right? So next, I'll give the second set of input. Let's say x is equal to, I'll give another input from a different class, 1, 1, 1, minus 1 I'll give, and I'm assuming, I'm expecting the target to be minus 1. Okay, the target is minus 1 because of this reason. Okay, so in the now what I'm going to do, I'm trying to give first let's calculate the z value. What happens to the output, we'll calculate. Okay, so z equals to, right, it's each of the weight into the input. So first is 1 into 1, second is plus again 1 into 1 plus 1 into 1, and there is a minus 1. Okay, and the bias, so minus 1 and a plus 1. This is because of the bias. We know that these will cancel, so z becomes equal to 3, right? So when z is equal to 3, you can see that y becomes equal to sigma of z. So this is sigma of 3. Sigma of 3 means it is plus 1, correct? So this is not equal to the target. So whenever this is the case, I just have to update. So it indicates that you need to update your weight, the bias. Okay, now, so moving on. So let's try to update the weights and the bias. So equation for weight updation, W1, let's update the old value of the weight plus alpha into the target. You can see that target is -1 into the input. First input is 1, right? So this is 1 minus 1. So first weight becomes equal to 0. Similarly, calculate the second one. Second weight, W2 is equal to old value of the weight, that is 1, plus alpha into target into this. So this is also equal to 0. Okay. Then W3 is equal to initial value plus alpha into the target into, right, into the input. Input is 1. Third input is also 1. So this is 0. Then calculate. W4 is equal to old value. Old weight was 1 plus alpha is 1, target is -1, and the fourth input is -1, right? So you can see that the fourth input is -1. That's why this is -1. So because of this, now this is equal to 1 plus 1. So we have 2 as the answer. So W24 becomes equal to 2. Then now calculate B, bias. So bias is equal to old value of the bias, that is 1, plus alpha is 1, target is -1. So this is 1 minus 1, 0. Okay, so we got for all the values updated, right? Now what we do, we give the third input. So the third input is like this. So I'll give the third input now. So let's say the third input x is equal to -1, 1, -1, -1. Okay, and the target is +1 here. Yeah. So the z value becomes equal to, we have to take the, this is -1 into 0, so 0 plus first three values will be 0, correct? Then we have -1 into 2 is -2, and bias becomes equal to 0 into -1, correct? So this is equal to -2. So because of this, what happens to the y now? Y is equal to sigma of z, that is sigma of -2, which is -1. And if you look at the target is +1, right? So this is not equal to the target. So because of this, not equal to target, right? So this implies you need to update. So now we'll update the weights and the bias because it says that we have to update its current value. So first three weights are 0 and the fourth weight was 2, correct? So now let us try to update them. So this means W1 is equal to old value of the weight, which is a 0, plus the equation says that it is alpha into target into the input, correct? So the alpha value is 1, target is 1, and input was -1, right? So this means the weight 1 becomes equal to -1. Similarly, W2 is equal to old value 0, alpha is 1, target is 1, and the input is +1. So this is 1, right? So W3 is equal to old value 0, plus alpha into target into the third input is -1, so you have -1 here. All right, so W4 is equal to, just check the previous weight. I think W4 was a value. Okay, this was 2. So W4 is equal to, this is 2 old value plus 1 into 1, because alpha is 1 and the target is 1 and the input is -1. So 2 minus 1 is 1, and the bias gets updated in the following fashion. Old value of the bias 0, correct? Bias is 0, and to this bias add the values. So alpha is 1, target is 1, so the B becomes equal to 1 now. So the weight and the biases get updated in the following fashion. Okay, so this was the third set of input which we were giving, correct? And now let's give the fourth set of input. Okay, and the fourth set of input is 1 minus 1 minus 1 1 for class -1. All right, let's try to do that. So x is equal to 1 minus 1 minus 1 1, 1 minus 1 minus 1 1, and for this I am expecting a target is equal to -1, correct? So for this case we are getting z as 1. This implies y equal to sigma of z, that also becomes equal to 1, and since this is not equal to target, right, you need to update. Okay, and let's look at the updated values. Okay, this is how we update now. So the old values of weights will be used to update. So what's the value of W1? W1 is equal to old value -1 plus alpha is 1, target is -1, into the input is +1. So this is -2, correct? So this becomes -2. Very similarly, let's go for W2 value. W2 is equal to old value of W2 plus 1 into -1 into the second input is -1. So this is minus of minus is +1 plus 1. So this is +2, correct? Then let's move on to the third way. Right? So W3 needs to be updated now. So old value of W3, I think it was -1, right? So W3 is equal to -1 plus 1 into -1 into third input is -1. So this is 2. Calculate W4. W4 is equal to old value of the weight, which is +1 plus 1 into -1 into the input is 1. So this is 1 minus 1, so 0. And update the bias using old value of the bias plus 1 into -1. So this is also 0. Okay, so we got the values of the latest weights and biases as right. So now our objective is to move on, since it didn't get trained, right? You can see that there was no training. Training was not proper. It couldn't detect all the inputs, and it couldn't classify the inputs into the corresponding outputs. Correct? So our objective is now to go for an second epoch, epoch, epoch number 2. Right. So epoch number 2 refers to giving the same sets of values once again. Now x is equal to give the first set of value with the same target. Already we have given that, but I want to start with this weights now. I don't want to start with 0 0 0 everything 0. I want to start from here. Okay, I want to start with these values as my initial weights and want to give all the possible inputs which I had given earlier. In a sense, it refers to the same question, right? Start from the beginning. But the initial values are not 0 0 0 0 value. No, not this. Okay, don't take this as the values, and you need to start from the uh, current values of the weights. All the four sets of inputs and targets needs to be given as input and train the machine once again, but starting from this. Okay, so this is what is our target now, right? So we will be training the machine once again, right, using those sets of inputs, right, and the targets, but the weights and the biases are the latest values which we have as of now.